Okay, so today we're going to look at section 5.5, and we have a main question here we want to look at, and that is, how do we measure the height of something where you can't use a ruler? For example, if they have a tall building or a tall tree or a mountain, how do they measure the height of these things? Because you can't drop a ruler down. There's not a ruler long enough to do it. Well, that's what we're going to explore in this lesson. To do that, we need to talk about some definitions on some things. And we're going to look at two kinds of definitions that are going to be used in our word problems: angle of elevation and angle of depression. What are those? Let me see if I can focus just a bit more. Angle of elevation is an angle that is formed from the horizontal, upward, and along a line of sight. So if your eyeball is here, you're looking along this line to an object. Okay, that's the line of sight. The angle from the horizontal to that line of sight is an angle of elevation. Okay. Angle of depression is the same concept, just in the downward fashion, like if you're on top of a building. The angle of depression would be looking straight ahead and then looking down at the object that you want to see along the line of sight. That angle that is formed by that action is an angle of depression. You want to keep these definitions in mind because we will be using those in a lot of word problems. Okay? So with that in mind, how do I measure something that I can't drop a ruler down? We're going to use what's called the trig ratios. You may have seen this in your geometry class. It's usually the first place where you will see it. So these are your trig ratios, and they are in a right triangle. The trig ratios are a relationship between the side lengths and an angle. That's what the trig ratios are. It's a relationship between the lengths of the sides of the triangle and the angles of a triangle. There are three main trig ratios that we're going to be using to solve our problems. This is called the sine function, the sine ratio, sine of angle A. So this is all part of it. So you have to have the sine and the angle complete. It's not, that's a sin. We don't do that. Okay? So this is the sine of angle A. This is called the cosine. I'll write the word here. Here's the sine. This is the cosine. And this is the tangent. So that's what you say. Don't say tan, don't say cos. It's the cosine of angle A, and these should be in parentheses, and the tangent of angle A. The sine of angle A, its ratio is defined as the side length opposite angle A. So here's angle A up here. The side length opposite that would be over here across the triangle from it, divided by the length of the hypotenuse, which is the longest side of the right triangle. Okay? And we can remember that as opposite over hypotenuse. Opposite length over the hypotenuse length. The cosine of angle A is the length that is of the side adjacent to angle A. Adjacent means next to. Divided by the length of the hypotenuse. Adjacent over hypotenuse. And the tangent of angle A is the opposite length divided by the adjacent length. Opposite over adjacent. With these three ratios, as long as you have two side lengths of a triangle, you can find the third, okay, in an angle. So you need to have two sides in an angle, and you can find all that kind of stuff, okay? And so the way to help us remember this little process here, these little ratios, is we just use the mnemonic SOHCAHTOA, okay? And so that kind of helps you remember these ratios. Some things to keep in mind. We can use these ratios to find missing lengths and even angles. So some questions you're going to be asked to ask, they'll give you all the side lengths, but they won't, you're asked to find the angle. If that situation occurs, even though I'm not going to talk about it, you're going to use these three ratios, which are called the inverse trig ratios. These are called inverses. These are things that will undo these. And by undoing it, it gets us to the angle that's in there. We'll talk more about this in the future, of what those actually mean. We'll explore it in more detail. For right now, if I ask you to find an angle, know that you're going to use these ratios depending on which one of the trig functions you have, and here's how it would look. If I have the sine of angle x equals 1/2, then if I want to get to the x, I have to take the sine inverse of both sides. See? So I put the sine inverse and then everything in parentheses, sine inverse and this side in parentheses, see? And then these two things will cancel each other out. They're undoers of each other, and you're left with just the angle x. That's how you get to it. This is how you would display it. Once you get to this point right here, since we are not familiar with this function, other than with the use of a calculator, we'll use a calculator at this point, and I'll show you how that works in just a little while. Again, we'll explore these functions in more detail in a later unit. So that's what we need to know. Let's go do some problems and see how this all works out. All right. So here's our little classwork page. We'll do a couple of problems on here, and then I'll save some other ones for our work in classroom itself. So we can pick one of these two problems up here. It doesn't matter. Let's take number 2. All right. So I look at number 2. I'm looking to see the relationship that I have given to me. So in this picture right here, I have this angle. This is the right angle. So that makes this the hypotenuse. So if this is the angle I'm looking at, I need to identify, is my information an opposite side length, an adjacent side length, or an hypotenuse side length? Because of that information will determine which of the 3 trig functions I want to use. Since I was given in my picture this angle, this is the hypotenuse, and this is the side length that is adjacent to the angle, which means next to, I need to have the adjacent and the hypotenuse function, which is the cosine. The cosine of an angle is the adjacent divided by the hypotenuse. So that's what we have. And so we're going to take these numbers and put them into that formula, or that ratio. So I have the cosine of 57 degrees. Remember, because we have radians now, you got to put the degree symbol, or otherwise you mean a radian. Adjacent means is 17. The hypotenuse is x. And so I have this proportion right here. I call it a proportion because this is a number. This is one object here. Don't see it as 2 things. It's one thing. And I can write it as a fraction. So then I can solve this by cross multiplication technique. So multiply the diagonals. Okay. And the quick way to get it all in one shot, I always tell people this, since you have an x in this one corner here, there's 4 spots. So multiply the diagonal that does not have the variable, and then divide by the third number. So x will equal 17, multiply the diagonal, and then divide by the third number, which is the cosine of 57 degrees. You can also just cross multiply and solve for x, which gets you here to the same way. Okay, multiply that diagonal, so you would get x times the cosine of 57 degrees equals 1 times 17. Then you can divide both sides by the cosine of 57. And you get right to where I had it over there. So you can go this route also to here. This is the exact answer, but we want to have a calculator version of this answer, a decimal form rounded to 3 decimal places. Okay, your default setting is always 3. Even though this up here says 2 decimal places, you can do that because I said to do it there, but I prefer 3 decimal places. We take our calculator, and we're going to type this in. So I get the glare out of here. So since it's a fraction, I'll use the fraction button. 17, and then the trig functions are all sitting right here in this button. You click on that, and you'll see all the different trig functions that we'll be using in the course of time if you go higher in mathematics. But here's our first 3, and you see underneath them, those are those inverse ones we talked about. So this is where you can find all these things. But for now, we have the cosine. Select it. It'll give you the parentheses, and you just type in 57. Oh, I forgot to check something first. And you need to check this also. Make a note of it in your notes. Right up here where the little gear is, it will, if you hover over it, it will tell you what your angle is in. I am currently in radians. So this calculator will read 57 as 57 radians, not degrees. I need to fix that or I'll get the wrong answer. You must always check your calculator to make sure that you are in the proper one. So you can just click right on that arrow, that gear, and it'll allow me to go into the settings in the general for me. And right here, you'll see where it says angles. Just go down there, select to the right, and change it to degrees. Double check this every single time. Okay? Do not do a problem until you have checked it. And once you change it, it's important that you always make it the default. Otherwise, it will only do it one moment. And then the next time it will go back to where it was before. And you'll start getting wrong answers if you do multiple problems. So once you change it to degrees or radians, just make it the default. And said, okay, we'll make it the default. And now I'm back in here. And now you'll see it over here. If I hover over it, now I'm in degrees. So when I hit enter now, it's going to give me this answer, and it's going to read it as the cosine of 57 degrees. I want to have a decimal approximation, so remember to hit control and then enter. And there's my decimal representation, rounded to 3 decimal places. So in this case, it is 31.213. These two answers are your answer that I'll be looking at, this one and this one. Make sure you have displayed both. When I look for your work and I grade your answers, I look for this step, and that. These are the 3 things I look at. You can do this step, but these are where I'm looking. The problem set up, you solved for X exactly, you approximated it down on the calculator, and that's my response for those. That's what I'm looking for those, okay? If I continue down to the next grouping over here, we'll just stick on this side over here. We'll take number 4, find the value of each trig ratio, and find the measure of the angle. So this is one where I'm going to look for how do I find the measurement of the angle. So in this case, I'm looking for the sine of Z, angle Z. So I look here, here's angle Z. And so to find the sine, I need to know the opposite over the hypotenuse. So the trig ratio for sine of Z is the opposite over the hypotenuse. And that is the first thing they wanted. That is the trig ratio. Now they ask us to find the measurement of angle Z. So from this right here, I need to get to this angle, so I have to try and undo a sine. So this is where I showed you that thing before. So you're going to write it as the sine inverse of the sine of Z equals the sine inverse of 21 over 29. I will need to see that line also. This 2 things undo each other, which gives me back to just angle Z. And then I have this right here, the sine inverse of 21 over 29. I will be looking for that line right there for credit. And then you can approximate this out using your calculator. Here's how it's done. So again, we want to get into our trig sine inverse. We showed you is over here in the trig button. So just click on the trig button. And the sine inverse is right below the sine. So we just select that one, see, sine inverse. We're already in degree mode, which is good. We'll get our answers in degrees. We're going to type in 21 divided by 29. I can type it as a fraction, or I can just type it as 21 divided by 29. I can do it that way also. Control Enter, and that gives me my answer in degrees, rounded to 3 decimal places. So this will become 46.397 degrees. Circle that as your answer, and this is what I'll be looking for. This is how you want to display your answer, okay? And let's see. We can do one more here. Let's do the pilot. A pilot sights an airport from her plane. The angle of depression is 28 degrees. If the plane is at an altitude, that means height, of 11,000 feet, how far is it from the airport? So based off of this story, you draw a picture. You don't have to draw the actual plane. You can just draw the triangle. Here's the plane right here. The line of sight. So this is where the airport is over here. Okay. And so this is the line of sight. The altitude of the plane is 11,000 feet. So where is this angle of depression then? The angle of depression, remember, is if you're right here from the horizontal, so I always draw out the horizontal line, downward along the line of sight. This is 28 degrees. You need to make sure you get the right angle that's described in the story. So once we're here, okay, and we're trying to find how far from the airport we are, this is how far we are from this direction. That's why that's labeled as X. So to use the trig ratios though, I need an angle inside the triangle. 28 degrees is not inside the triangle, it is outside the triangle. Okay? So how do I get an angle that's inside the triangle? Well, there's a couple of ways to do it. It depends on how much you remember from your geometry. Because this is horizontal and this is an altitude, I know that this is a 90-degree angle. And so then if that is 28 degrees, then this has to be 90 minus 28 degrees. Okay? And what's that going to be? 62, I think. So if I add those together, do I get 90 degrees? Okay? And that's what this angle here is. See, now I have an angle inside the triangle. This is one method for getting an angle in here. Another one from geometry is this. This is a horizontal line. This is a horizontal line, the ground. This is a line that transverses those. So this is a line cut by parallel lines cut by transversal. Since these are both parallel to each other, then I know that alternate interior angles will be congruent. So because of these things being parallel, I know that this angle right here is also 28 degrees. Because in parallel lines cut by a transversal, alternate interior angles are congruent. So in doing a problem like this, you have to decide which method you're going to use and then use that angle, okay? You got to get an angle inside the triangle. So with that, I come over here and I can just finish this problem out. Now since I wrote on my paper, I'll just keep writing on it. Let's say you chose the 62 degrees. Then this side is in relation to 62 is the adjacent. This side is the hypotenuse. Adjacent and hypotenuse talks about cosine. So the cosine of 62 degrees is the adjacent divided by the hypotenuse. And then we can multiply, cross multiply, and solve for x, and we will get x equals 11,000 over the cosine of 62 degrees. But what if you did this one? Am I going to get the same answer? Let's find out. If I use this angle, then this side is the opposite to that angle, and that's the hypotenuse. So that requires us to use the sine ratio, which is opposite over hypotenuse over x. So if I cross multiply this one, I get x equals 11,000 divided by the sine of 62 degrees. Wow. Let's see what happens. We got a calculator. We'll start with this one. 11,000. And this is going to be the cosine of 62 degrees. Gives me that number. And let's do the next one, and we'll compare them. 3. And this one's the sine I'm sorry, I put 62 in here. That my fault. That is not a 62. I used the wrong angle. This is 28. 28. There we go. This is the angle I used. Opposite over hypotenuse, 28 degrees. There we go. Almost made a mistake there. And then we hit Control and Enter, and you'll notice it's exactly the same answer. Okay? So you can use any angle you want to make that work. And so X is approximately 23,430 and 599. And our measurement length is in feet. So that's how that works. And you can see that any one of the two angles will give us the same answer as long as you use the proper trig ratio. So that's how that works. That's how angle of depression works. Again, remember, do the drawing, put your angle in there according to the definition of angle of depression or angle of elevation, and then make sure that you have an angle in the triangle or you cannot use the trig ratios. And so that ends this video. We'll do more examples in class.